Welcome to solverfy.
This problem is a bit of a long one, but I've written down a few things here. So the pH is given as of the buffer is given as 8.88. The base is the concentration is 0.4 molar, and the concentration of the conjugate acid is 0.25 molar, and the volume that they've given us is 0.25 liters, and we're going to use that information throughout this whole problem. So first we need to find the pKa, and we're given the pH of 8.88, and we're given the concentrations. So we can plug these in. Whoops, it's the wrong number. So 0.4 molar over 0.25 molar. Okay, and so we rearrange the equation. So we'll read pKa equals 8.88, and when you take that log of that number, then it's subtracting 0.204. And so now we just subtract that, and we find that the pKa equals 8.676. Okay, and we're going to use that later, so we need to remember that. Next, we need to figure out the initial moles that so that we can figure out how many moles were added to it and what that will end up being. So all we do to figure that out is we take the volume times the concentration of both the acid and the base. So for the acid, it's 0.25 liters times 0.25 moles per liter. And as you can tell, the liters will cancel out there pretty easily like that. And the answer we get is 0.0625 moles. Now for the base, all we do is we take the initial volume, which is 0.25 liters, and we multiply it by the concentration, which is 0.4 moles per liter. Again, the liters cancel out, and the answer we get is 0.1 mole. Okay, so then we take these answers and we move here. When the hydrochloric acid is added, this is the equation, and so essentially what is happening is you add the acid and it goes into the base component of the buffer, and so you subtract, as I've indicated here, this is the base, the B. This is the equation here. So you subtract the initial moles minus the moles added. Okay, so it's being taken out. And then, as we can see here from this equation, as it goes, the acid has 0.002 moles added in, and so we just add that equation. So that's all we have to do. For the first one here, we take 0.0625 moles plus 0.002 moles, and that equals 0.0645 moles. Pretty simple, pretty straightforward. So that's our final moles here. And then for the base, we have 0.1 moles, and we subtract 0.002 moles, and that equals 0.096 moles. And that's our final moles for the base. Okay? Now we need to find the concentration of the conjugate acid and the base. And I've written down here, so the concentration of the acid here equals the final moles over the volume. And that's the definition of molarity. And we measure concentration in molarity. And then I just, to save space, I just wrote this is the same equation for the base, the concentration of the base. So I'll fill this out here. The final moles was 0.0645 moles, and the volume is 0.25 liters. Okay, and the answer for that is 0.258 moles per liter, or molarity, which is a big M. So that's for the acid, and for the base, we just take the 0.098 moles over 0.25 liters. That equals 0.392 moles per liter, or big M. Okay? And then we take those concentrations and plug it back into the Henderson-Hasselbalch equation. And this is where we will need the pKa of, we go back here to the first screen, 8.676. 8.676 plus the log of, and if we go back here to this screen, so the base is 0.392 over, and the acid, its conjugate acid, is 0.258. And we just plug that into our calculator, and we find that the pH after this is 8.86. And that's the answer to the question.